Hi everyone, welcome back. So on this very fourth question, which is the last question on our worksheet, we have an introduction to systems, which is basically what we're going to be discussing for the entire semester. So many physical systems, such as the motion of a car, can be modeled using a system. Oftentimes, when we're describing a system, we will have a state variable, x, that will often be a multivariable function. So state variable, it has to capture the state of a system, the entire state of the system, okay? Now for a given system, we can often write a differential equation describing its change over time as dx of t over dt being equal to f of x of t u of t. In this problem, we will examine a specific form of systems that can be put in state space representation. Now for a continuous time linear system, the general state space representation can be written as d dt x of t being equal to a x of t plus b u of t. In the discrete time system, we're just going to be using recursive difference equations instead of differential equations, writing xn plus 1 being equal to a times x of n plus b times u of n. So in either case, a and b, they're matrices, right? So in the case of an RLC circuit, as we have analyzed before, we might use a VC, the voltage across a capacitor, and IL, the current flowing through an inductor, as our state variables. So typically when we have multiple state variables, what we do is that we just concatenate them into one single vector to make computations a little bit easier for us. Okay, so now we want to consider the following system with these two differential equations with this initial condition where x1 of 0 is equal to 2 and x2 of 0 is equal to 3. So what is the state vector for this system? So as we have explained earlier, when we are faced with multiple state variables, what we do is that we just concatenate them into a single vector. So we say x of t is equal to x1 of t, x2 of t. Okay, that captures the whole state of the entire system. Now, for part B, what is the initial condition of this system? This is pretty simple. We just plug in the value t equals 0. See that this is x1 of 0, x2 of 0. So x1 of 0 is equal to 2, and x2 of 0 is equal to 3. Right? Now, after part C, we want to write out the system of differential equations, the form of a general continuous time state space model, which is the form outlined here. Okay, so to do that, the first thing that we need to do is that we need to write out d dt x of t. Okay, we know that the derivative of a vector is just the vector of derivatives, and this is just going to be equal to d dt x1 of t d dt x2 of t. And d dt x1 of t, we know that this is equal to 3x1 of t minus 2x2 of t plus 4. Okay, plus 4. And at the bottom, d dt x2 of t is equal to negative x1 of t plus 5x2 of t plus 2. Now, we just separate these terms into two individual vectors for the sake of clarity. And the first term, we want to express this as a product of a matrix with our original state vector. So this is going to be equal to 3, negative 2, negative 1, 5. x1 t, x2 of t. So this is what we define as our x of t, right? And for the vector, it's just constant, so we just keep it as is. And this just concludes our walkthrough for this question as well as the entire worksheet.